On Monday we started to look at synthetic division on finding zeros of polynomials. If we look at this first problem again, I want to show a little bit how this connects to long division. So in long division, if we wanted to divide 456 by 8, put the number we're dividing by outside, we think 8 does not go into 4, but 8 does go into 45 5 times. 5 times 8 is 40. 45 minus 40 is 5. Then we bring down the next number, 56. 8 goes into 56 7 times. 7 times 8 is 56. Subtract 56 minus 56 is 0. And so what this is telling us is that 8 multiplied by 57 is equal to 456. That 456 has two of its factors are 8 and 57. So in polynomial division, if we are given a factor of x minus 2, we can divide this polynomial by x minus 2 to find what the remaining factor is. So just like we had in synthetic division, we have to write down all of the terms, starting with the leading term, and then making sure that we include every single degree possible that is less than the leading degree. So x to the third, we don't have any x squared, so I have to put 0x squared minus 19x plus 30. So we have x to the third, x squared, x, and a constant. So if I'm going to divide these by x minus 2, I kind of ignore the minus 2 part and focus on the x, since that's the larger degree of these two terms. And I need to think, how many times does x go into x to the third? Well, x times x squared is x to the third. So I find the x squared term and put x squared right above it. And now I multiply x squared times x minus 2. So x squared times x is x to the third. X squared times minus 2 is minus 2x squared. And so now we're going to subtract that from the original polynomial. X to the third minus x to the third is 0. 0x squared minus negative 2x squared. Minus a negative means we're going to add 2x squared. So 0 plus 2 is 2x squared. Bring down the next term, minus 19x. Now we look at how many times does x go into 2x squared. And so x times 2x is 2x squared. So I find its like term and put positive 2x up on the top line. And now 2x times x is 2x squared. 2x times negative 2 is negative 4x. So now I want to subtract those. 2x squared minus 2x squared is 0. Negative 19x minus negative 4x. So minus and negative means add 4x. Negative 19 plus 4 is negative 15x. Bring down the plus 30. Now I want to think about how many times does x go into negative 15x. What do I have to multiply x by? Well, it already has the x, so I just need the negative 15. So I put the negative 15 over the constant, and then I multiply. Negative 15 times x is negative 15x. Negative 15 times negative 2 is positive 30. So if we subtract these, negative 15x minus negative 15x is 0. 30 minus 30 is 0. So I have nothing remaining, nothing to bring down, and so this means that x minus 2 is a factor because it goes in evenly. There's no remainder when we write it this way. And so what we're finding is that x minus 2 times x squared plus 2x minus 15, these two multiplied together give us our original polynomial x to the third minus 19x plus 30. So how does this look compared to synthetic division? And so what we did on Monday was we took that polynomial x to the third plus 0x squared minus 19x plus 30. And the first step was to write down the coefficients for each term. X to the third has a coefficient of 1, x squared has a coefficient of 0, x has a coefficient of negative 19, and the constant is 30. Now the factor that we wanted to divide this by is x minus 2. Well, the part that we're interested in is when we multiply each of these, the x is already taken care of. That's always going to subtract, but it's the minus 2 that we're interested in. And so we have to, with synthetic division, we use the 0 instead of the factor. So if you think x minus 2, what makes that equal to 0? Well, if we add 2 to both sides, we find that x equals 2 is our 0 when x minus 2 is the factor. So it's just the opposite of what this value, it's the number that's being subtracted. So this 2 is what we put inside this half of a box. Now, synthetic division, instead of subtracting a negative, we're going to be adding. So we took care of that minus sign by changing this to addition. And so 1 doesn't have anything to add to it, so we just bring down the 1, or 1 plus 0 if you prefer. And so now this number, this 1x squared, is getting multiplied by the 2 to figure out what goes down below. And so the 2 times 1 comes up here, and it's being combined with the 0. So 0 plus 2, 0 plus 2 is 2. So then this number gets multiplied by 2. So this 2 here came from the 2x that we had up above, and now it's getting multiplied by 2 to get this minus 4x. So 2 times 2 is 4, and now we're adding negative 19 plus 4, which is negative 15. Now this negative 15 is getting multiplied by x, and negative 15 times the 2. Negative 15 times 2 gives us the 30. In this case, 2 times negative 15 is negative 30, because we're going to subtract 30. That's our minus 30 here. 30 plus negative 30 is 0. That's our remainder. That's telling us that this factor went in evenly. And what we're left with, we started with x cubed, but when we divided by this factor, x cubed turns into x squared, 1x squared. The x squared term, we took out an x, and we're left with just the x term. And so that's the positive 2x. And then the x term, we took away the x, and we're left with a constant, negative 15. So the numbers on the bottom are the same as the coefficients of the top of our long division. The numbers here in that second row, after we multiplied by 2, is this 2, 4, and 30 that we found in the long division. And so what we're finding is that synthetic division is just a way of doing long division, except getting rid of all of the x's and x squareds and x to the thirds. And so it simplifies the math while accomplishing the same thing. So I hope this helps explain why synthetic division works. Now let's flip over to the back side of the page for this next video to look at some more examples of using synthetic division.